Hey everyone, welcome back to the channel. Today we're diving into the fascinating world of chemistry with a compound you might not have heard of, acenaphthene. Don't let the name intimidate you. This polycyclic aromatic hydrocarbon has a story to tell, from its intricate structure to its real-world applications. In this video, we'll break down what makes acenaphthene tick, explore its properties, and even peek into its safety and commercial side. Stick around. This is going to be over 5 minutes of chemistry goodness. Let's jump in. So what is acenaphthene? It's a polycyclic aromatic hydrocarbon. Say that 3 times fast. That just means it's made of multiple rings of carbon atoms fused together, with some hydrogen atoms along for the ride. Its chemical formula is C₁₂H₁₀, 12 carbons and 10 hydrogens. Picture this, 2 6-membered benzene rings, like hexagonal honeycombs, sharing a side, and then a 5-membered ring squeezed in between them. It's like a molecular sandwich. This structure isn't just pretty, it's stable and flat, which affects how acenaphthene reacts chemically. Its molar mass is 154.20 grams per mole, a handy number for chemists measuring it out in the lab. Oh, and if you're looking it up, its CAS Registry Number is 83329. That's like its chemical social security number, unique to acenaphthene. This fused ring setup is what we'll keep coming back to. It's the key to understanding its behavior. Let's get physical. Acenaphthene has some cool properties that tell us how it acts in the real world. Boiling point, 279 degrees Celsius, when it turns from liquid to gas. Way hotter than boiling water at 100 degrees Celsius. Think industrial-grade heat. Melting point, between 90 degrees Celsius and 95 degrees Celsius. That's when it goes from solid to liquid. For comparison, chocolate melts around 30 degrees Celsius. This stuff needs a bit more oomph. Density, 1.06 grams per cubic centimeter. It's slightly denser than water, which is 1 gram per cubic centimeter, so it would sink if you tossed it in a glass. Flash point, 135 degrees Celsius. This is the lowest temperature where its vapors could catch fire with a spark nearby. Safety alert. These numbers aren't just trivia, they're clues to how acenaphthene behaves in labs or factories. High boiling point, it's stable under heat. That flash point, it's a heads up to handle with care. Now here's where it gets serious. Acenaphthene comes with warning labels, an exclamation mark and a flame symbol. The exclamation mark means it can be irritating. Think itchy skin, stinging eyes, or a scratchy throat if you breathe it in. The flame? It's flammable, so a spark near those vapors at 135 degrees Celsius could spell trouble. How do you stay safe? If you're handling acenaphthene, like in a lab or workshop, gear up with gloves, goggles, and a lab coat. Work in a ventilated space and keep it far from flames or hot surfaces. Store it somewhere cool and dry, sealed tight. It's not a monster, but it demands respect. Chemists out there, any safety tips you'd add? Drop them in the comments. Ever wonder how acenaphthene gets into the hands of scientists or industries? It's sold commercially in different sizes. 5 grams for $50 USD. Perfect for small experiments. 100 grams for $90 USD. A step up for bigger projects. 500 grams for $290 USD. That's industrial territory. These prices are in USD, but acenaphthene travels globally. Product codes like 20134-0050 or 20134-5000 keep orders precise. It's a peek into the chemical supply chain. Think of it like online shopping, but for molecules. Who's buying? Researchers, manufacturers, maybe even environmental scientists. Which brings us to, what's acenaphthene good for? It's a building block for making dyes, plastics, and even some drugs. Its rigid rings are perfect for crafting complex molecules. It also pops up in environmental science. Since it's a PAH, it's released from burning stuff, like car exhaust or coal, and scientists track it to study pollution. Here's a wild one. Acenaphthene has been eyed for organic electronics, like OLED screens in your phone or TV. It's not the main player yet, but it's got potential. On the flip side, it's not super friendly to the environment. High exposure might irritate or worse, so it's a compound with pros and cons. There you have it, acenaphthene unpacked. From its triple ring structure to its fiery personality, it's a compound that's small but mighty. I hope this dive into C₁₂H₁₀ sparked your curiosity. What's next? Maybe another PAH or a totally different chemical? Let me know below. If you liked this, hit that like button, subscribe, and ring the bell for more science adventures. Thanks for watching. See you next time.